for chapter 2, and then we're going to do lab 2, which isn't a whole lot. It's just kind of going over like some of the information from Atlas A, some of it from chapter 1, where we talked about like body position, terminology, and that sort of thing. All right, so these chemical reactions and understanding metabolism. So when we talk about, now, once again, this is going to go back to the importance of water. Because if these chemical reactions either have to build up something or break something down, we are either going to need water or we're going to give it off. So when we talk about the synthesis or the anabolism, the putting something together with synthesis. Now let's look at this picture. Down here, okay, it's showing me some molecules. Do you guys remember amino acids from bio or anywhere? Okay, if you remember, amino acids strung together make a protein. All right, so when we talk about this type of chemical reaction, if the bond is made, meaning we take two parts, for example, and we put them together, all right, the bond that gets created stores energy. Okay, so another piece of these reactions that take place. These types of reactions, they're very important. They help us grow. Once we're fully grown, it helps with maintenance of the body. It helps with repair of the body. Now note what happens in putting these two amino acids together, these two parts. If I have amino acid 1, amino acid 2, on the first one, note they're trying to point out this group that is OH, this group that is H. What gets formed if you've got H2O? Water. So if I put those two together, that's what broke off. And therefore, a bond was made, energy was stored, and water was given off. That's kind of cool, okay? So, because water broke off, they tend to say it's dehydrated because water was given off. Does that make sense? If we lose water, for example, we're dehydrated, okay? So, when we build something, we store energy, and we gave off water. So if we look at catabolism, decomposition, the breaking down, if I have a big molecule and I need to go in and break a bond, for example, table sugar, one of my favorite food groups. All right, I know it's not really a food group, but y'all know what I mean. That is a disaccharide. Two molecules together. Our body can't use that. Our body actually has to break it down into its component parts so that we can use it. To break it down, I've got to break a bond. Now, where do they happen to show the bond getting broken? Between an oxygen and an OH. Once again, water, okay? So, my body has to actually supply a water molecule. And by doing that, it breaks the bond, and H goes to the O, HO to the hydroxyl group, and I now have 2 glucoses, the smallest molecule our cells can use. And I can now utilize that sugar I ate. So these are examples of this importance of either building bonds, breaking bonds, and in breaking this bond, because when I think of table sugar, okay, think of like food sources that I've eaten. I'm eating because I need energy, and if I break the bond, I gave off energy.
Is water the only thing used to break bond?
Now, think about that. Did everybody hear the question? It was, is water what's always used? Yes. Because that is, under normal circumstances, we should be about 75% water, and our cells should be roughly 75% water. So, we are working at that cellular level to keep these reactions going. We're working on these reactions in the blood. We are working on these reactions in extracellular fluid. So all of these are water environments. Some of these reactions that will occur are reversible, meaning if we have our reactants and we make a product, the product can break back down to become reactive. It can be reversible. Now, that becomes important as we continue to study, because one of the things that we need to keep in mind, we need to keep our tissues at an equilibrium. What happens, for example, if we don't keep our body hydrated enough? Like, I don't know, it used to be, they told us 8 glasses of water, 8 ounces, 8 times 8, 64, okay? That's what I grew up with. Now, it's more of, okay, the water you need is going to be based on your physical activity, your weight, all this sort of stuff, okay? So now, it's like you have to kind of do all these, like, mathematical equations and, math. How many of us really like to do math? Okay? But we have to like do these mathematical equations to figure out like how much water am I supposed to have? But let's just go with the norm that it used to be of 64 ounces. And that does mean water. Not soda, not tea, not coffee, not energy drinks, not juice, okay? Water. How many of you in here get that amount per day that you are supposed to get? No. Okay? I mean, it takes like really true dedication to get that full amount. Okay? I mean, yeah, granted, I'm like, I've got my tumbler, all right, that I have, and I'm like, okay, well, I think this is supposed to be 39 ounces, so technically if I drink 2 of them per day, I should be getting okay, blah, blah, blah. Anybody else kind of like have that problem of just really don't want to drink it anymore? Yeah, okay. Now, this is why, one of the reasons, why it becomes important. We have to make sure that that water inside and outside the cell is at equilibrium. Another reason for that, if we do, okay, we not only are, creating a good environment for chemical reactions, but It also affects how fluid your blood is moving through your heart. Have any of y'all seen the little like pictures and stuff that they kind of put up about, oh, you know, it's a good idea as soon as you wake up to drink like the 2 glasses of water as soon as you wake up to avoid the heart attack, okay? And it's really because, you know, they're talking about how you've been asleep all night, you haven't consumed water, that sort of thing. And the reason that they kind of like know that that's a good idea is because your body's been doing a whole lot of reactions throughout the night while you've been sleeping, and it's a good idea to replenish that water. Keep that blood flowing easily through the heart. I mean, we don't want to put any pressure on the heart, and we don't need to. So one of those reactions that can just go back and forth is the water. And that helps keep cells in a healthy environment. Those ions that form, and I'm not going to spend a lot of time on this right here. I just want you to understand what the term oxidation means and reduction, okay? Because when we have ions form, oxidation is when we have those elements come together, the element that lost the electron. Okay, we say oxidized. The one that gained it, we say was reduced. It's actually kind of backwards to what you would normally think. The reactions that occur for this to take place are called oxidation reduction reactions. Simply meaning somebody gave up an electron, one of those atoms, elements, gained it. Okay? So not going to spend a whole lot of time on that because that gets really deep into chemistry. As these chemical reactions occur, one of the things that happens, we either stored energy or we gave off energy. Energy, the definition, the capacity to do work. We have different types of energy that exist. We have potential energy, kinetic energy, mechanical energy, chemical energy, and heat energy. Potential, just like the name implies, it has the potential to do something. Therefore, if we have a molecule and the bond hasn't been broken, it has the potential to have energy, to do something. Kinetic means energy in motion. We're already breaking that bond, we're already using that energy. Mechanical is energy that helps us move something. Chemical energy is energy in those chemical bonds, and heat energy is what is given off as we do chemical reactions. Metabolism, if it is the sum of all the chemical reactions of the body, this means we are building bonds, storing energy, breaking bonds, giving off energy. This helps contribute to maintaining our body temperature. The chemical reactions that occur in the body help to maintain our body temperature. People who have higher metabolisms, temperature tends to be a little higher. People that have lower metabolism tend to have less body temperature.